Yeah, very good morning. Today we are going to see about the load forecasting. Okay, how the forecasting load is being forecasted. Okay, so what are the techniques to forecast and how the forecast is happening. So already we have drawn the load curve and load duration curve. How we have drawn the load curve and load duration curve? Based on the problem given in the sheet. Okay, in the problem, so one exact load is being recorded and it is being given in that problem. So what we did is we simply plotted the curve. We simply plotted the curve. But if you comes to the when it is comes to the like a substation or generating station, this forecasted data, that is load curve and the load duration curve of whole 1 year. So what they will do is after every 1 year, they will plot at December 31st or January 1, they will plot that year's data. That year's data. So why to plot that year's data? In the sense to forecast. Okay, to forecast what is the next year the same day. Say for example January 31st. January 31st. What is the load? Maybe. So by seeing that forecasting data, that is load duration curve, so we can easily find out in which are the load is maximum, so that in which are we have to generate the maximum approximately. We can't to predict very accurately, because no one in this world can predict the load accurately, that is load demand accurately. So it may changes. It may changes. The changes we are making it more. Say for example 13,000 megawatt is the today's load. Nah? So we are making it to some 13,500 megawatt. We are generating 500 megawatt more only. Why? Because suddenly the load may get increased. Suddenly the load may get increased. Suddenly the load may get decrease also. Suddenly the load may get decrease also to 12,500 megawatt. So in that scenario, will drop if the load is that load drop persist for some more than half an hour or 1 hour, then definitely they will drop. They will not simply drop it for 5 minutes if the load is very less, for 5 minutes, 10 minutes. So if the load demand is less for more than a hour, like 1 hour, then definitely they may call to particular some generating station. So whichever is more costly, so that particular generating station, they may ask to stop. They may ask to stop, like a thermal power station, or like a thermal in the starting itself. They may tell, like in the morning 4 o'clock itself, they may tell, like so this might be the generation, this might be the demand, so you on 4,500 megawatt, like that. So simply stop how like only power station simply we can stop is wind, and the wind is almost free. So definitely they will touch the hydro one. Okay, so 99% they may touch the hydro power station only, because easy to off. Okay, within 10 minutes or 15 minutes, it is easy to off. Okay, so if you simply close that valve in the valve house, you go to valve house, if you close that valve, so automatically the water flow in the penstock will be stopping. So automatically everything they may off. So that is that. So very easy. It may take only 5 minutes to off the hydro power station, because water we can't wasted up. No. So simply like that, we are not wasting of the water. Okay, so we can store that water for future purpose. So whenever the demand is maximum, then simply we can on by that like water in the dam. If we keep the water water in the dam, then we can use at any time. So that might be useful for the two purpose. One is for agriculture and as well as the your power generation. Okay, so here the forecasting is an essential process of any successful company, especially when production oriented or trading oriented. Okay, so wherever the forecasting might be there. So even the production companies, if you take like production companies, small materials they are producing, say for example water cans, 1 liter water cans, small. So they have to predict, whether the product is selling daily, say for example monthly, this many product is getting sold. So 1 lakh product is getting sold. So based on the 1 lakh product, we may also able to produce the production, like in that particular company, in one day itself, like 10,000, 20,000 pieces you can manufacture. So only 1 week you can run the, if you run for 1 week that particular company, so you can easily um, uh, match with the resource, resource, whatever the resource, like 1 lakh pieces you need, 1 lakh pieces you can generate in a 1 week itself. After that, you can go for maintenance. Then you can go for producing new designs, new models. Okay, in the market, who will win the market? Only the person with if you come with same product, if you come with new designs, it might be useful to care, it might be having some glitches to catch that particular bottle. So it is very easy. Okay, very easy, so that your product sale might be increasing. And if you nowadays, if you go for like steel bottles or copper based bottles, so your product will be like anything, because plastics almost we are not using anywhere. So maybe few may be using, but if you go for copper bottles, definitely. So forecasting is a very important thing. Okay, so production and also trading forecasting. So which district is mostly that product is buying, in which district mostly that product they are buying. So that particular districts you have to concentrate, and particularly, so you have to increase the marketing also, ads, advertisements. If you increase in the particular districts, then your product sales might be anything. So someone, what they will do is they will directly go to the schools. They will give to all the students. They will give to all the students. Then later they can collect, or the fees they may collect, like that also they may, like a school, like 2,000 students may be there. So they will distribute to almost all the students with their name also, printed with the name. So like different ideas, then definitely they may succeed in the market. So forecasting often associated with operation research with inventory management problems. So like R&D company, if you work in any company, so definitely research and development department might be there. Without that, your company, okay, so maximum profit is coming from the R&D department only. R&D department is come up with a new design, then only the market, you can win the market. So we can win the market only by research and development. So whatever the company you take, like a cycle, you take cycle manufacturing company. So daily they may change the designs. They may change that bars, maybe like a cross bus, like that. Simply they may change, and the wheels they may change, and the gear cycles means gear cycle 5 gears, 6 gears, 8 gears, like that. They may just simply change, so they will succeed in the market. So if you buy that particular cycle means, if you run for only 1 kilometer, means with that gap, it may run for another 2 kilometers. So 3 kilometers you can run. Okay, you have to pedal for only 1 kilometer, but with that gear wheels, so 2 kilometers extra you are getting. Like that, some different new models they may think. Even in the electric companies also, like switches are getting changed like anything. So nowadays, no, due to smart homes, nobody is installing the switches. So all came in one remote control itself. So by sleeping in the bed, by lying on the bed itself, you can on your fan, you can on your light, you can on your television, TVs, like all the products integrated in one remote itself. Okay, so smart homes, they are giving one remote with one two lights, one fan, some appliances. So if you simply press that button, you can get that thing. And even one step more, with the mobile itself, you can, the mobile app itself. So if you want to on that particular room number four fan, means if you press that room number 4, the fan will get on. So if you want to decrease the speed of the fan, so okay, that process also comes in the mobile itself. So if you decrease that thing automatically, so 1 to 10. So if you want 5, 6, 7, 8, 9, 10, so whatever the speed you want, you can increase that speed. So like that, you have to make one operation research inventory management, so that your products also will get engaged. So industries, other industries where forecasting plays a critical role, including marketing, okay, financial planning, and as well as service industries. Service industries also. So what they will do is, in service industries, they may not give the 100% working product. Okay, some components, even in the LED TVs, some capacitors, what they will do is, they will make that capacitor for only 2 years only, like some number of hours. So daily they are running 8 hours TV in a day. So 8 into 365 days into 2. So this many hours only that capacitor may work. Okay, so then only what you will do is, after 2 years, okay, 1 year they may not give. 1 year means free. It is that service is free of charge. Okay, so that is loss for the company. So 2 years warranty capacitor they may install. So what it will do is, after 2 years, suddenly a small line will come, like blank line will come. So in that, what you will do is, you will call to the customer care, and one person will come, and he will charge for transportation and thing, some 350, 400. Again, for that one capacitor, he may charge around 500 rupees or 400 rupees. So approximately 1,000 rupees you need to spend. Even most, like that is the marketing strategy. That is the company sales. So no product in this world with 100% life, 100%. If they give like that, that might be the losses for them only. Even any product you tell, I will tell you that some fault might be there. Okay, so some in cycles also they may give some like some like a gear also, they may give only for only 2 years or 3 years warranty. Okay, if you continuously run that cycle, 3 years only, 2 years only, that gear will come. So if you want that gear setup, you need to spend like 5,000 rupees, 4,000 rupees. Even 4,000 rupees, you can buy one small cycle also, like without any gas setup, you can buy one cycle also. Like that, they may manufacture. That is their marketing strategy always. Okay, so in some companies, like electrical companies, what they will do is, the conductors and all, they may go for long life. Why? Because that conductor we can't go and simply cut, and we can't change. Okay, so in the deep forest range, and again the height is very high. Okay, like 100 meters, 50 meters, and all, you have to go up, and you have to install that wire. So in that scenario, the company itself, they may go for more profit. Okay, So per feet or per kilometer, only they may buy that conductor. Okay, so 50 kilometers they may buy, 100 kilometers they may the conductor. So 1 kilometer cost itself they may go for with a high profit. Why? Because once it might be sale, otherwise only thing is that if fault occurs or trees falls on the particular conductor, then only you can change. Otherwise, you can't change that particular conductor. So simply like that, what they will do is they may go for more like a more profit. Then only they may get back. Okay, so that also there. So here forecasting is a key element of decision making. Okay, so even in our power generation also, forecasting is a key element. Okay, so if you forecast only, we can generate that particular amount without any risk. Okay, so it is a purpose to reduce the risk in decision making and reduce the unexpected profit or cost. Okay, so if you didn't forecast, say for example, today didn't your electricity board didn't generation corporation didn't forecast that particular power. So simply like that they are generating. Okay, so instead of 13,000 megawatt, they are generating only 10,000. 3,000 megawatt is the deficit. So 3,000 megawatt means definitely on three or four districts maybe not getting the whole district itself not getting the power. Okay, so four districts, three districts not getting the power means definitely that might be the loss. Tariff rate also might be decreasing, or otherwise that particular district people, what they will do is they will come for a protest, we will not pay this month electricity bill, like that they may come for the protest. So that might be the loss for that particular generation company. So correct forecast, you can get more profit. Okay, so correctly you will be giving the service. So you can also add more also in the tariff. So like 1 to 500 units, 1 to 500 units, 6 rupees. After 500 units, 8 rupees or 10 rupees. Like that you may charge. If you give correctly 24/7 reliable supply, so that consumer also what they will do is they will enjoy. We are the consumers. So if we are getting reliable supply, we definitely will on all our ACs, ceiling fans, everything. So we will also enjoy. The generation companies also will be enjoying. Why? Because they will get more profit. Okay, after 500 units, you will be charging with some 2 rupees, 3 rupees extra. Okay, so 3 rupees extra means, so in per unit, 1 unit, 3 rupees extra means, so sometimes definitely you will be consuming 1,000 units. Like AC, if you are using AC, more than 1,000 units. So if you are using ACs and all, definitely more than 1,000 units will consume. So their electricity bill, if you take like 6,000, 7,000, 8,000 rupees. So 8,000 rupees means definitely that might be the profit for that particular generation companies. Okay, then yeah, production theory for electrical power system is formed by economic load dispatch and unit commitment. Okay, so production theory, like economic load dispatch, you can find out the least cost generators. Okay, least cost generators and also unit commitment. So after finding out the least cost, you can commit which unit is least cost, like that. Say for example, 10 these 10 units, 1, 2, 3, 4, 5. From this 10 units, so 1, 3, then 7, 8. These are the least cost generators. Means these units only we can commit, so that our cost also might be reducing. Okay, production cost also reducing, so that the profit also you will be getting more from the electric power generation companies. And also inventory theory for electrical power systems is based on fuels and hydro schedule. Okay, so inventory theory, so fuel, how much coal you need. Okay, this much tons of coal you need. Like that, we are forecasting. Just like that, without forecasting, um, like if you are buying the coal, suddenly there might be a deficit. Means again we can't able to buy. Okay, so again you have to put the process, and they may take again for finalizing the rates. They may take again 1 week, and transportation it will take another 5 days. So 10 days you have to wait for the coal to come. So based on the forecasting, so 1 month forecasting. So this much tons of coal you need. Okay, so that this much ton for 1 month you can store in the coal yard, means cold storage yard, means you can simply utilize. So that is also in the forecasting. Hydro scheduling also based on the amount of water in the dam. Based on the amount of the water in the dam, what they will do is they may predict. So this much TMCs of water in the dam. So with this dam, if we daily utilize 8 hours or 6 hours, so we can generate the power for like 100 days. And if the incoming flow of the water from the river to the dam is so this much TMCs na, so daily so averagely this much TMCs na, daily you can generate the 8 hours of power for 100 days. Like that, forecasting also they may done. Okay, and also fuel scheduling. Fuel scheduling is achieved by optimal search of various raw resources available in existing contracts and open markets. I think in the restructured power system, you may study all these things. I will explain you later. Then these policies were found in the previous part. Okay, previous part of the text. So a competitive environment requires price forecasting as well as demand forecasting, as the revenue received from the sale has to exceed the cost of the production. So electricity price forecasting. Okay, so simply like that, say for example, generation companies, they are generating 13,000 megawatt. Okay, so per unit they are spending around 10 rupees. Say for example 10 rupees, but with the subsidized cost for domestic users, they are giving only for 5 to 6 rupees. Okay, so 6 rupees they are giving. 4 rupees, how they are managing means from industries they are getting more, and three-phase supply and commercial tariff they are getting more. They are managing with that. Okay, so they have to forecast. Forecast means this much 13,000 megawatt we are generating. So with that 13,000 megawatt, so 6,000 megawatt only utilized for only domestic loads. So again, 7,000 megawatts utilized for industrial loads. So 6,000 megawatts means 6,000 megawatt for this many hours, 24 hours in a day. So what is the amount spent in a 1 day? Okay, so and also 7,000 megawatt into this many hours, 24 hours. So 24 hours they are going to generate for so into particular 12 rupees or 18 rupees. So we may get this much amount. So this is the our we spent this much amount. Okay, this much crores of amount for 1 day. So we are getting more than that. Like the profit also they may get now. So more than that. So that is good. Okay, so like how it is happening means forecast. Okay, simply like that, forecasting the charges, that is tariff, forecasting the tariff. So this much amount we are getting means, so the profit may be this much amount. So that profit and also maintenance cost, then the salaries to the employees, then the loans, the World Bank, they may get from the loans for constructing the power plant. So that has to repay for 20 years means, so that loan amount, interest amount, everything they may include in the profit. So with that profit only they can give. So without profit, if they give not, that might be the loser. Okay. So forecasting is the essential component for all functional operational function, includes transmission maintenance scheduling, unit outage scheduling for maintenance, nuclear fuel reset. So if you forecast, you may get to the so when you have to go for maintenance. Like that also you can do. So say for example, nuclear power station. Nuclear power station is running for 20 hours in a day. So 20 hours in a day means like 4 hours daily we can get. So 4 hours daily we can get. So if you forecast properly, that 4 hours you can go for maintenance of the particular unit itself. Unit 1 you can go for maintenance, or otherwise unit 2, like that. This is also due to the forecast. This also might be happen for the forecast. And forecasting is a key driver into marketing, financial planning, and labor policies. Okay, so labor, yearly you have to give the increment to the laborers. Yearly you have to give some increment to the laborers, some percentage, 5%, 8%, 10%. You have to yearly you have to give the charges to the salaries to the laborers. So that also done by the forecasting. How? So our company profit is this much. So if we increase the product rate yearly up to 1 rupee or 5 rupees, so we may easily give the salaries increment to the salaries to the employees. Like that also they may predict whatever predicting is coming, like that is nothing but forecast. Okay, forecasting. So you also forecast your life, after 2 years, after completion of this 2 years PG, MTech degree. So where we will work. So meanwhile in 5 years, where we will work in the government sectors. Meanwhile in 10 years, we'll settle with the government job, or we'll settle with some good companies, like electrical companies, power generating companies, like that. Some forecasting, that is also forecasting. So forecasting obtained by qualitative and quantitative analysis. Qualitative technique perform the forecast based on the results of the expression or one or more experts, or personal judgment or opinion. Okay, so just a calculation only, expert calculation only. Okay, so this much TMCs of water available means how much daily, for if you run that power station for 8 hours or 10 hours. So how much days that particular water will come if the incoming of the water is this much TMCs. Like that, that is a simple forecasting. Okay, simple calculation, mathematical calculation. But practically, if you take, almost all dams in the world, or in India, if you take the forecasting, so each and every one has to do the forecast. So that forecasting will take the time. Say for example, in a particular India, you have to fully forecast. So how many dams are there? It might be of 100 dams might be there. So like 100 dams, I'm including all the small dams, everything. So 100 dams you have to forecast. For hydro generation means it is very difficult by writing in the pen and paper, like one dam, this many TMCs. So this much power generation. Second dam. So like that, it will take some 5 hours, 6 hours, 10 hours to forecast system. So that's why we are going for neural network techniques. Even whatever it may be, long-term or short-term forecasting, we are going for neural network calculating by using the neural network techniques. I'll show you. Yeah, this is the simple demand forecast applications. Okay, so demand forecast, automatic generation control. Okay, so next 15 minutes, the forecast interval is 5 seconds. So economic load dispatch, next 30 seconds. 30 seconds forecast interval. But even you have to calculate in the very fast time. Very fast time. Then only you can tell that particular, 3 generating units itself you are writing by pen and paper, you are taking 30 minutes. Minimum 30 minutes to solve that problem. 30 minutes. If you give with some demand is not satisfying, and that generation is not satisfying means minimum 30 minutes it will take. So imagine like in a state like 100 generators are there. Say for example 100 generators are there. That sorry, 50 generators are there. 50 generators you have to forecast. Okay, forecast. If you with a pen and paper for sometimes now, I think it may take 20 hours to forecast and maybe more than that also, one day also. Within that time, the one day will be over. So whatever the calculation you did for that day, that might be over within that day. So that's why, like, if you go for some intelligent algorithm and as well as the neural network techniques. Neural network, as I already told many examples about the neural network. Simply like that, if you give whatever the n amount, n number of generators, say for example 1,000 generators, 1,000 generators you are giving the data. Okay, you want forecasting and also least cost generators. Okay, so simply like that, if you program in neural network, that 1,000 generators in the almost all over India or all over the world, you want the whole forecasting of the all over the world. So simply like that, what all the things that is, simply give the data to the neural network within some 1 minute or 5 minutes, it may give the answer. Maybe so 1,000 generators means it may take some more hours also, like maybe 15 minutes. 15 minutes is not at all. It's okay. 15 minutes or half an hour it may take. So even like 40 generators, it may take in seconds. Maybe some 30 seconds or 60 seconds, 1 minute, maximum 1 minute. So simply like that, what they will do is they may not go for the calculation by writing in the paper like that. So they may have that program, intelligent program. Simply like that, they may feed what are all the generators, 40 generators or 50 generators, they may feed the data. So installed capacity also they may feed, and also working condition. Installed capacity will be more. Say, like in thermal generating units, installed capacity might be of 4,500 megawatt. But how many generators, like how much how many generators in operation means maybe 1 or 2. So that might be of 1,500. So which are the which are the generators in operation? That data also if you feed now, automatically so, and also cost. Fuel cost function we solve now in economic load dispatch problem. So cost functions. So these are the cost functions. So this much cost for first generating units, this much gross. Second generating unit, this much gross. So automatically, if you feed in the within 1 minute, you can get the least cost generators. And also, if you predict, if you want to give the maximum demand, like today, we are predicting, we are forecasting like today's maximum demand is like 13,500. So if you give like 13,500 for 13,500 megawatt, I want the particular generators, least cost generators. Automatically, the answer they may get, you may get the least cost generators. So that least cost generators, if you simply email to that particular generating station, automatically due to the intelligent program, if you email like Kottagudam power plant, 1,500 megawatt, like that, automatically they that persons may be seeing that email like second by second, minute by minute. So like simply like that, okay, Kottagudam power plant 1,500 megawatt. So 1,500 megawatt means 2 generators we have to on. First 1,000 generators we have done, another 500 generators, 500 megawatt generator you have done. So simply like that, in every every generating station you make it. And also sometimes they may tell to load dispatch centers. From the load dispatch centers, you might be receiving call. Okay, call to all the generators. Like from the, if you simply pass on that message to load dispatch centers, from the load dispatch centers, maybe 10 generators may be connected. So easily 10 members you can easily call, or otherwise you may update also. Okay, so in the SCADA system, if you simply update, like in the demand might be of 1500 megawatt, or email. Nowadays many communication devices are there, or through phone call, so automatically they may start the generation. Okay, so morning 4 o'clock itself they may tell to every generating station. Okay, because from 6 o'clock the load might be simply starting like anything, increasing or decreasing, decreasing like that. So from 6 o'clock they may start their generation up to next like midnight 12 o'clock, or otherwise next day 6 o'clock. So they will be given with the command how many hours that particular generators has to operate. And also wind forecasting, um, like what is the velocity of the wind? Velocity of the wind means like 45 kilometer per hour. Okay, if the wind speed is 45 kilometer per hour maximum, and minimum is 15 to 10 kilometer, 15 kilometer per hour only, they may run that particular wind turbines. If it is less than 15 kilometers per hour, even though if they run, the efficiency might be dropping. Okay, so efficiency might be dropping now. Definitely they may stop that. Okay, so if your vehicle is giving only 10 kilometers per liter, say for example your two-wheeler is even it has to give like 60 kilometers per liter, but only it is giving 10 kilometers per liter. Now you may not take that vehicle outside. Why? Because the cost of the petrol is almost 100 rupees. Okay, 100 rupees you are spending, 100 rupees you are spending for 10 kilometers, means it is very loss for you. So definitely human being nature definitely will stop that vehicle, and we may go by auto, or we may go by public transport, like, or some other vehicle. So similarly in wind turbine also, they may not simply on. Okay, they may not simply on. So simply like that, they may on only the wind velocity is 15 kilometers per hour. More than 15 kilometers per hour, they may on. So then only the efficiency might be somewhat they may get. And also hydro forecasting, already I said. Fuel scheduling also I said. So similarly, like OPF, contingency analysis, stability analysis, like that things are there. And one more thing I need to tell, all this load forecasting is based on stochastic process. Stochastic process means, what is the meaning of stochastic processes? Random process. Okay, randomly we are going. Okay, so randomly we are selecting, say 50 generating units in particular state, means 50 generators we are taking, and randomly we are selecting based on the cost. Okay, random, all are random only. And also like intelligent program also works on the random process. It may not give 100% accurate results. So no system in this world, if it is giving 100% efficiency, no system in this world is giving 100% efficiency. Even your brakes also, like car brakes and bike brakes, it is not giving 100% correct braking thing. 99.9% or 99%. Okay, in TV advertisements they are giving, no, it will kill the germs of 99.1% or 99.9%. They may not give 100% efficiency. Even any product, like mobile phones reliability, then your two-wheeler advertisement, they may give like a 99.9% efficiency, but they may give one small star in the top. So if you read that star, the terms and conditions, so it will give the 99.9% efficiency only if you run that particular vehicle in national highway and only with the 50 kilometer per hour, you should not cross. And only the petrol is grade 1 petrol, with grade 1 petrol, and the climatic condition, temperature is of 37 degrees Celsius. Like that, they may give some conditions. Okay, if you run the same vehicle in -4 degrees Celsius, it may not give that much efficiency. Like that, they may give like a star, terms and conditions. So that also, the no, so even your intelligent program also will not give 100% correct accurate result. It may give 99.9%. I will explain you in some other class why it is giving 99.9% efficiency, like that. So it might be very interesting. So 99.9% efficiency. So you may run, but it is almost 100. 99% is almost 100. Okay, so it is okay. You can 1% might be some tolerance. Even you can't predict correctly. So that 1% and 5% tolerance only, we are generating more, 500 megawatt more for sometimes, and automatically based on the demand, we are suddenly dropping our load, or sudden increase in the demand, we are making the some other generators also simply to on. So that also possible.